welcome to another one of Reigate College's maths videos. This time we're talking about integration 1, so we're going to go over the basics of integration, how it works, and just kind of go through some basic examples. I'm going to deal with the more difficult, the more extended problems in a later video, so make sure you watch that when it goes up. So one of the most important things with integration before we integrate is an understanding of the laws of indices. Now I've put them up here, I'm not going to go over them again. Kyle's already gone through them in differentiation 1 with some examples, so if you want to revise those, go and check out that video. Obviously, an understanding of what integration is incredibly important. So we've already seen that to go from y to dy by dx, you have to differentiate. Which Kyle and Ash have already dealt with. Integration is going the other way. Essentially, in terms of core 1 and core 2, that's one of the main purposes. This understanding that to integrate, you are undoing differentiation, is a really important thing to be aware of. So, our rule for differentiation was multiply by the power, reduce the power by 1. If we're doing it backwards, we need to reverse that set of operations. So you increase the power by 1, then, that's really important, the order of this is incredibly important, then divide by the new power. And that's kind of the phrase you've got to keep in your head when you're doing basic integration for core 1 and core 2. So let's look at the general rule algebraic. So the key thing is that this ax, that's going to stay there. This notation here, with this weird elongated s and the dx, tells us we're integrating. Now that notation is very, very important. This bit tells us we are integrating. We're integrating ax to the p, and then this dx means with respect to x. All that means is that x is the thing that follows this rule. Any other letters that we've got kicking around, don't do that. And that's all that means so far. But in terms of what you need to write down for integration, those have to be there. Because it tells the examiner, tells whoever's reading your maths that you are integrating. So we start with ax to the p. So following our rule, we increase the power by 1. So our power goes from p to p plus 1. The a on the front, remember a is just a number, it's a constant, stays there. And then we divide by the new power. So whatever this number is, we divide by it. We're going to look at a couple of examples in a moment with some actual numbers in. But there's also something very important that you need to remember with integration. And it's a plus c. We call this the constant of integration. And when you're integrating without numbers on the integral sign, it needs to be there. We'll look at y in integration 2 when we get onto a part of integration which is called solving differential equations. So it comes up a little bit in core 1 and core 2, and in a big way in core 4, in the upper 6, when you start looking at that. But for now, you just need to know that if you don't have numbers here, the plus c has to be there on the end. It's incredibly important. In terms of definite integration, well, that's what we call it when we've got numbers on the integral sign. We refer to these numbers as limits. We call them the limits of integration. Again, we'll look at why we do this, why we need to do this definite integration in a later video. But for now, we're going to look at just how you do it. Essentially what you do is you take whatever this is, integrate it, plug in to that, the top number, plug in the bottom number, and then take one away from it. And that gives you a number that this is equal to. So let's look at some examples. In sort of a similar way to differentiation, these can be worth quite a lot of marks in Core 1 and Core 2. Sort of basic polynomial integration. Depending on how many terms you've got, the difficulty of the powers, and so on. Like differentiation as well, for Core 1 we only need to deal with positive integer powers. We don't need to worry about if we've got an x to the minus 1, x to the minus 3, 1 over x to the 1 over 2, something like that. Yeah, we don't need to worry about that for Core 1. Don't panic if you've got brackets here. Generally, the questions in the exam will have brackets, don't necessarily need them. But it's nice to have them. So, we are integrating 3x plus x squared with respect to x. Again, notice how I've still got these bits of notation. Doesn't matter that we've got things added together, just do each one as it comes. So, 3x, well, that's 3 times x to the 1. Don't write the 1. So, we've got x to the 1 here. I'm going to put it in for now. Add 1 to the power, so 1 plus 1 is 2. The 3 stays on the front, and then we divide by the new power. Do the same thing with the second term. 2 plus 1 is 3. Divide by the new power. And then we've got to remember our constant of integration on the end. Now some people might write this a little differently. Doesn't matter which one of these you use, they're both the same. Yeah? They mean the same thing, either's correct. The examiner's not too fussed by which one you write down, as long as it's right. So let's have a look at a slightly differently worded example. This is going to work exactly the same way, just it's written differently. Again, like with differentiation, if we've got brackets, what have we got to do with them? Well, we've got to expand. It's up to you how you expand. You can use a grid method, a FOIL method, and you can use Kyle's toucan if you prefer. I like to use the smiley face. So, we've got 3x squared, and we've got minus 2x plus 3x minus 2. See, it forms a smiley face, which is 3x squared plus x minus 2. It's entirely up to you when you want to do that expanding, whether you want to do it right at the start or before you start introducing some integration stuff. I don't mind which, as long as you do it. So let's actually integrate. So with this one, it just says integrate, so I need to remember my integration sign. Notice how I'm still writing out, more or less writing out the question. It's really good practice to do that. Now we've already expanded this, So we can just go ahead and integrate like we did in the previous example. Notice I haven't put brackets. Probably should, but you're not going to lose marks if they're not there. Okay? Again, increase the power by 1. The number on the front stays there. Divide by the new power. Increase the power by 1. Divide by the new power. Now we've just got a 2, or a minus 2. If you are ever integrating a number, well, that's technically x to the 0. 0 plus 1 is 1. Anything divided by 1 just stays the same. So if you're integrating a number, just stick x next to it. And remember our constant of integration. This is correct, but we can go a step further. It's always good practice to, if you can cancel down fractions, you should. Core 1, you can sometimes get away with it. Core 2 and beyond, you will lose marks if you don't cancel down the fractions properly. So be careful with that. So that's looking at 2 relatively straightforward integration examples, but they're examples that could come up in any Core 1 exam. This one, the example 1 that we did, you've got 2 terms that you're integrating, probably worth 2 or 3 marks. This second example here, we've got 3 terms, maybe 3 or 4 marks. 4 marks if you like it. Let's look at a more extended example here. Now, this is actually taken off an exam paper. This question is worth 5 marks. So it's a decent number of marks, given that it's very similar to the examples we've just done. So, let's start by integrating. So, let's integrate as we normally do. So, increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power, and so on. Now, the main difference is that this one has got numbers on the integral side. You've got the limits. So what changes with our question? Well, for a start, they still need to be there. The other thing, we don't write the plus c. You don't need to know why you don't write the plus c for this example, but if you're interested, go on to My Maths and work through the My Maths presentation on this, and it explains it for you. In terms of our notation, once you have integrated, that's the key thing, you still have to integrate. You put square brackets around your answer, and you move your numbers to this side. Now what do? Well, we plug in our numbers. So, when x equals 2, it's our top number, we get, so our x to the 5 over 5 plus, notice how I'm going to cancel this down now, x cubed plus 2x. We just plug 2 into that. 2 to the 5 over 5 plus 2 cubed plus 2 times 2. Obviously, Core 1, you don't have a calculator. Core 1, you're going to have to deal with some relatively unpleasant fractions. I don't like using decimals for this. I think decimals are a waste of time for integration. Fractions, much better. Again, with Core 2, you should really know your powers of 2. Yeah, up to really 2 to the 5, 2 to the 6. We'll be able to work them out very quickly. So you've got 2, 4, 8, 16, 32. 8 plus 4. So we've got 32 over 5 plus 12. How do we add together fractions? Well, we need a common denominator. We've already got the over 5 here, so we want something over 5 here. 12 is 60 over 5. So we get 92 over 5 for our first part. We're now going to repeat that process for x is minus 1. Okay, so again, now because we're dealing with negative numbers, you need to be very, very careful with your brackets. Okay, it's really important to keep up with your brackets when dealing with negative numbers. It's nice they've given us 1 to deal with, because, well, 1 to anything is 1. You've got to remember that when you've got an odd power, so 5, 3, the negative numbers stay negative. So you get minus a fifth, minus 1, minus 2. Which we get minus 1 over 5 minus 3, which minus 1 over 5 minus 15 over 5 minus 16 over 5. Okay, we've got our 2 bits. The last step is we do this number, take away this number. Again, being careful that we've got a negative. So, therefore, remember this 3 dots, these 3 dots means therefore, we've got the integral between minus 1 and 2 of x to the 4 plus 3x squared plus 2 with respect to x is equal to our first number take away our second number. We've got a minus and a minus becomes a plus. We've already got a common denominator, so we don't have to worry about that. And we get 108 over 5, and that is our answer. As I said, we'll look at what that means in terms of this graph, this one here, in a later video, and we'll look at the other application of integration as well. Hopefully that's been useful, and thanks for watching.